Hey everybody, it's Mr. Dugal. Today we're going to talk about working with corresponding sides, and this is in reference to dilation or scale factor. So basically, they might give you a shape. We're going to start out with a rectangle, and they're going to state that the figures are similar, so you don't have to worry about wondering if they're similar or not. So you might have an image that's 12 by 5, and next to it you have this is going to be a pretty simple example to start, and then we'll move on. You might have another image that's like this. Side note, these two images are not drawn to scale for the numbers I'm going to use, but this image might be 20 and this be 48, and the question might say, what's the scale factor? So it might say just scale factor. Determine the scale factor based on the corresponding sides. Now, I'm purposely starting with an easy image. Many of you already can see what the scale factor is. It's times 4. But the important thing is to see this. So there's a proportion. We can call this side to bottom or side to top. It's really side to side to top to bottom. Where if we take the original and new, it will be proportionate. So the side of the original is 5, the top is 12. On the new, the side is 20, the bottom is 48. So basically there's a few ways we could look at this. We could say from left to right, do we see any multiplying effect? And the answer is yes, we see that it's times 4, which means that's a scale factor. If we go left to right, that means that is the scale factor. There are times where we might also realize a proportion top to bottom, which will help us solve for a side, but it's not going to be our scale factor. In this case, the top to bottom doesn't go in evenly. That's not a great way to look at it. And finally, we can also determine sometimes by cross-multiplying and dividing to find the missing side length. There's 3 ways that we can operate once we have our proportion set up. Just to be completely honest, full disclosure on this one, I don't think you even need to do that. I think you can just kind of eye it and see that it's times 4. But don't worry, it will get harder. So we might have a trapezoid, and this trapezoid might have a small base of 6, a larger base of 14. A height of 12, and side lengths or diagonals of 15. And we got a new trapezoid. Again, not drawn to scale. So here's our new side lengths. Okay, now it's a little more difficult. And the question again might say, what is the scale factor? How I can determine the scale factor is I can go from left to right. So I can say 12 times question mark equals 27, or 6 times question mark equals 13.5. So I could have determined that from the very beginning. I could have gone 6 times what equals 13.5. The best way to just do this is to divide. We have 13.5 divided by 6, which is going to end up giving us 2.25. Our scale factor is 2.25. And if I took the time to go through each one, I would realize that yes, 15 times 2.25 is in fact 33.75. The other type of question that you might get asked in this regard is this. They might say, you have 2 similar figures. If the scale factor is 3/5, what's the new side length? Use the trapezoid again. 5, 12. Let's say they just give you the height this time, which they might do. And you have to find X, Y, and Z. In this case, remember it's not a division. It's if when we're multiplying by a number less than 1, our number is actually getting smaller. So in this case, X is 3. We're multiplying each side by 3/5. Y would be 24/5, equivalent to 4 4/5 or 4.8. Finally, we have over 1 times 3/5, which would be 36/5, which is 7 1/5 or 7.2. So that's another question they might ask you. But the most difficult thing, and what we're really trying to get out of today's lesson, is they might ask you both. They might give you a triangle and tell you that they are similar. But they might not give you the scale factor, and you have to find the missing side lengths. So say we have a right triangle here that's a 3, 4, 5 triangle. And they give me one side length. So maybe they give me the height of our new triangle. And it turns out that my height is 5.3 repeating. We're going to call these B and C to get you ready for Pythagorean theorem that's coming. So we have to find B, one of our, this is called a leg because it's adjacent to the right angle, and this is called a hypotenuse because it's opposite the right angle. B is a leg. We'll get to that in more depth at a later lesson. But basically it wants to know what the scale factor is, and what is B, and what is C. It wants all of it. And this is where I'd go back to what we talked about before. You could take 5.3 and divide by 4, and it will give you the scale factor, and then we could use that to find B and C. I'm going to write it out a little in a way that's a little more easy to follow. So we used a 4 as B is to 5.3. We do need to make sure that one of the sides is the height, or else we're going to end up with two variables. Say we took the leg and the hypotenuse but not the height. We wouldn't be able to solve because we would have B and C. We need to make sure that there's only one variable, and in this case there is. So if I look left to right, it's not a super friendly multiplier. Up and down, again, not a super friendly multiplier. These numbers were chosen on purpose because in this case the best way to probably do this is to cross multiply and divide. We got 5.3 repeating times 3, or that would be as a fraction 5 1/3 times 3. And on the other side we have equals 4 times B. Well, after I do a little multiplication, I realize that 5 1/3 times 3 is actually 16, equals 4B. Divide by 4, B, the leg, the base, is 4. The other information that this could give me is I can actually now find the scale factor. I could either do 5.3 divided by 4 to find the scale factor, or I could go 4 divided by 3. That's a little easier, so we're going to do that. 4 divided by 3 is my scale factor. And I start to see, actually, you know what, this repeats. It's going to be 1.3 repeating, or 1 1/3. So my scale factor is 1 1/3. B is 4, which means the last thing I need to find is C. And now that I do know what the scale factor is, I could set up another proportion like this, or I could just actually take my hypotenuse here, 5, and multiply by 1 1/3, and we're going to do it that way. It's just 5 over 1 times 4 over 3. 1 1/3 is 4/3 as an improper fraction, which gives me 20/3. So I know that C is actually 6 2/3. So that's how you would solve it if they're asking for both the new side lengths and the scale factor.